If you work in healthcare and you're not AI literate, you're about to be outpaced by people who are. I'm Dr. Dave. I'm an ICU doctor building real-world AI. And my goal is to make you AI literate in 30 days. No jargon, just first principles. The simple lesson today is that AI is just logic coded in math. And today we will cover how we can turn electricity into actual logic. We start off with the transistors, which are these simple switches for on and off. But a simple switch is not really intelligent. So what's the secret sauce? The secret is the logic gate, which are physical circuits that implement a rule, not and or. They're not just words, they're actual mathematical rules that are built out on transistors, arranged so that depending on the input voltage, the output wire is forced into a predictable state. A high voltage is 1, low voltage is 0. Most modern chips use CMOS, which pairs two types of transistors, the N-type and P-type, which we've covered in a previous video. The trick is that only one side should be winning at a certain time so that the output is a clean 0 or a 1 and not somewhere in between. Physiologically, a clean analogy would be the excitatory versus inhibitory input of a neuron. You've got signals trying to push up the membrane potential for depolarization, and you've got signals trying to clamp it down. Whichever dominates determines whether that neuron fires or not. And CMOS is exactly like that. One network tries to pull the output up, the other tries to pull it down, and the inputs decide which network gets control. Let's take an AND gate, for example. AND means the output is 1 only if input A and input B is 1. Everything else outputs a 0. In CMOS terms, an AND gate is often built by a NAND gate, which is not AND, which usually outputs 0 only when both inputs are 1, otherwise it outputs a 1. NAND is popular because it's efficient to build in transistor logic. They ultimately build a NAND gate and then add a NOT gate after to make it an AND gate. Imagine two sensors feeding you a decision. Is the patient hypotensive? Is the lactate elevated? Call those A and B. In digital land, each one becomes 1 or a 0. AND gate would only input 1 when both A and B are 1. The output could be used as a trigger for the next layer, like giving antibiotics in a septic patient, which is just another gate or a circuit downstream. In real medicine, it's obviously a bit more continuous and nuanced, but the chip level decision primitives are built out of these yes or no rules repeated at an insane scale. And these gates then chain into circuits that can add numbers and multiply numbers. And once you can do this multiplication and math really fast, you can do the core operations of neural networks, which is called matrix multiplication. That's the engine of inference. So when an AI outputs a sepsis probability, it's not magic, it's an astronomical stack of these binary decisions implementing logic through arithmetic to produce a final number. Follow and save this, and tomorrow we talk about memory, why machines have working memory and long-term storage, and why AI can forget things at times mid-conversation.